Okay, we are going to start A Maths revision already. Okay, you will find A Maths, the exam paper, so much easier than E Maths, you know. It's unbelievable, but it's true. Okay, the A Maths paper, not only paper 1, but paper 2, is easier than the E Maths papers 1 and 2. Yeah, okay. Now, let's take a look. I want to familiarize you with the formula sheet for A Maths. Now, first page will be a cover sheet, right, for the exam. Then the next page, right, will be a formula sheet. You must be familiar what's found inside the formula sheet. Now, first one is a quadratic formula, which you're very familiar with. Later, I will tell you how to use this. Now, the other one, okay, you won't be tested on binomial. It'll be next year. The other one is this trigonometry. So remember this three that you have learned, I told you it'll be tested, right? Now all the rest will be only be tested next year. Very good, thanks to COVID-19. And they will also give you this set of formulae. Okay, meaning to say, ladies and gentlemen, your sine rule and your cosine rule and your half AB sine C, that formula, right? You cannot forget that formula. Okay, because you might be asked to apply it in A Maths. I'll show you an example in the later video, not this video. Okay, let's start now. Now, this particular equation, which can be found in your formula sheet, okay, here, alright, which is your quadratic formula, actually helps you to do certain things. Okay, so you may ask me, what certain things are you talking about? Now, do you remember we studied this thing called the discriminant? Okay, the discriminant, right, is equals to b squared minus 4ac, right, where your a, b, c are the coefficients of a quadratic equation. Now, you must understand that a quadratic equation, very simple one, is in this form, right? And it can either be a happy face or a sad face. When will it be happy? When the coefficient of x squared is positive. So when you have this thing like this, or when you have 2 3 whatever, whenever it is positive, ladies and gentlemen, it's a happy face. When you have negative, minus 2 minus 3 whatever, then it'll be a sad face. Are we clear on that? Okay, now that's the first thing you need to know. Okay, the next thing you need to know is whether this equation will have whether this equation will have no roots, or no, when I say no real roots, no real roots, or whatever, right? Depends on this thing here. And because it depends on this b squared minus 4ac, we call this thing here a discriminant. It discriminates, okay? It helps us to distinguish whether it has real root or not. So don't you agree? Use common sense, class. Maths is all about common sense. I'm not bluffing you, okay? It's the only subject that is common sense, okay? Now, don't you agree that when you square root a negative number, your calculator actually won't give you any answer? So this is what we call no real roots. So when b squared minus 4ac is less than 0, you get no real roots, so this topic actually no need to memorize one. That's why you see in the formula list that I sent you, right? I didn't write anything about this because it's all common sense. Okay, so I think you are clear about this, right? Now, just like I told you before, there are many ways to ask what's your name, right? What's your name? How may I address you? You are, what do people call you? I see, we are all asking you what's your name, right? So same thing here, no real roots. Instead of asking you no real roots, right, they can say, oh, the curve does not intersect the line or does not cut the line. So let's say they say the curve y equals to x squared plus 2 does not cut the line y equals to x or 2x minus 3. If they say does not cut the line, this one, right, what must you do? Now, ladies and gentlemen, against its common sense, you have to change this x and y thingy, this x and y thing into ax squared plus bx plus c. And the only way you can do that is whatever you have learned in lower sec. You sub 1 into 2. Okay? Then you will get a quadratic equation. Are we clear? Then you will b squared minus 4ac and all that. Of course, in the examination, right, they can put here 2k lah, whatever. Then you will end up with some unknowns here. Okay, and if they say does not cut, right? Does not cut, that means your b square. Okay, I make things simple. Let's say you already sub 1 into 2 already. Then you end up with this. Let's say 2x squared plus k minus 1x plus 2. This one, right? It's now in the form ax squared plus bx plus c, right? Then you will b square, right? This is b, minus 4ac. Okay? And then you will say that this is less than 0 because the question already tell you does not cut. Do you follow? Okay? So that is what you need to know. Okay, okay, so that's b squared minus 4ac. Okay, we go through the basic first. Now, the second one is when this b squared minus 4ac is exactly equals to 0. Now, when it's exactly equal to 0, you plus or you minus 0, actually it's not doing anything, right? That means you only have one answer. Your x will only be minus b over 2a. So this is what we call, they will say maybe, the curve is, the line, let's say y equal to x plus 3 is a tangent to the curve y equals to, let's say, 2x squared plus 3x plus 4. Like that. Okay? That means this fella, which is this curve, you have this curve first, then the line is a tangent to this curve. Cutting only one point, but this is what we call the repeated root. It is considered two roots because when you solve this quadratic equation, you get x equals to maybe 2 or x equals to 2. So the two roots are equal. That's why we call it two real repeated roots or two repeated real roots. Okay? So this is what we call repeated roots. Follow? Okay. Now, in this case, can you see that your b squared minus 4ac must be equals to 0? This whole thing must be 0. Then this will disappear. Then there's only one one root, or what we call two repeated real roots. Okay, it's repeated because it can be x equal to x equal to Okay, so I hope we are clear. Now, this way is one way to phrase it. They can also say two repeated real roots. Okay, or if they say the line touches the curve at only one point. This and this and this, they're all saying the same old thing, that b squared minus 4ac is equals to 0. Are we clear? So that's what it's all about. Okay, now the third one and the last one, more or less the last one, is when this fella is greater than 0. Now, greater than 0 means maybe 1, 2, 3, 4. So when you take minus b plus a number greater than 0, let's say 20, over, let's say, another 25, 23 or whatever, right? You have plus and then you have another minus. So you have two roots, right? You have two roots. So this is what we call when your b squared minus 4ac is greater than 0. You have two real and distinct. Distinct means different roots. Now, let me clarify the difference between, okay, let's call this number 1, number 2, and number 3. Number 2, how many roots? Actually, it's 2. But the roots are the same. Sama-sama, iyang-iyang de, okay? Benda-ge. They're the same. Alright? But when I have b squared minus 4ac greater than 0, then this is too real and different. The values are different. So let's say I solve this one. I solve this one, right? Example. I solve this one, I may get x equals to minus 2 or x equals to 5. There? Two real and distinct roots, right? That's what it means. Alright? So I hope you are clear. Now, how to go to that side? I want to go right. Okay, never mind. Cannot go right. I go bottom. So in the last case, right, is when I combine 2 and 3 together. Then you say, what do you mean? 2 and 3, how to combine them together? The question may say, oh, the roots are real. Okay? There are 2 real roots. The roots are real. Or they can say 2 real roots are. When it's 2 real roots, right, it can be, ladies and gentlemen, greater than 0, or, which is this case, 2 real and different roots, right? Or it can be equals to, because it can also be 2 equal roots. The roots are repeated. Repeated means what? It can be like x equals to 2, x equals to 2. Okay? So I hope we are clear. Okay, that is all for the basic concept. Alright. We are going to do a real question now. Show. In this case, they are not telling you, they're not asking you for the range of values. They're asking you to show that this line, okay, cuts or intersect the curve at 2 distinct points for all real values of p. So what they're trying to ask me to do, okay, what they're trying to ask you to do is to show that this, okay, this is a happy face, right? You just draw a picture to help yourself visualize. Then it's not positive gradient, right? So it cuts at 2 points, 1, 2. So you see, if it cuts at 2 points, right, this b squared minus 4ac must be greater than 0, right? Because greater than 0, then you have plus a certain number, then you get one answer. Then you have minus a certain number, then you get another answer. That's why it is 2 different answers. Okay, are we clear? So now what's the first thing you do? It's always your lower sec. That's why your lower sec are very important. You didn't waste 2 years in nutshell. No, you didn't. Those years are well spent. Okay? Well spent, how you spend? You sub 1 into 2. Then this is your 1, right? There? This is your 1, you sub into 2. Why sub into 2? So that you remove the y. We don't want the y. Because we ultimately only want ax squared plus bx plus c. Okay, I write here. Ax squared plus bx plus c. So in this case, your a is 1. B is this fella. And your c is minus 1. Alright? Okay, now, after this, can we write, ladies and gentlemen, can we write b squared minus 4ac? You will need to ask yourself this question. Can you write b squared minus 4ac? Then you see, oh, you see 2 distinct points. You say greater than 0. Can we start like that? No. Once you do this, wrong. Why wrong? Because they asked you to show that it is like that. They want you to show this. Show. There? They want you to show this. So your this one, right, must be the last part here. You see or not? Must be the last part here. Oh, Must be the last part here. So what must you do first? You say, you need to find out what b square minus 4ac is first. So b, you square it. Must put bracket, minus 4ac. A is 1, this c is minus 1, okay? Then you become like that. Okay? Now, don't go and expand, ladies and gentlemen. Don't. You know why don't? Because it's already a complete square. It's already a complete square. So this question is actually a very simple question. So after this, what do? You must say, oh, since, you see, this perfect square, right? Perfect square is always greater or equal to 0. Okay, confirm. You must write this, always greater or equal to 0. Okay, now, okay, I show you all these steps. Okay, what's happening here? You, after you have found your b square minus 4ac, right? You must now work this out. That means you must like investigate whether this is greater than 0 or not. So how to investigate? Start with the perfect square. Perfect square, we know that it is always greater or equal to 0. Because I can put half, p as half, then 1 minus 1, 0 0 square is 0 that's why it's equal to 0 but it can never be negative. So this is always positive. Follow? Okay, then now, this one done already, right? Done already, Done already, Okay, now we got to do the plus 4. So the next step, you just plus 4 on both sides of the inequality. Now, isn't this the discriminant b square minus 4ac? And isn't it greater or equal to 4? Now, the smallest number you can have is 4, meaning that you are greater than 0. That's why I put here, greater than 0. Okay? Then you must conclude, since discriminant greater than 0, okay, they want you to show this, right? They want you to show two distinct points, Then you just say, finish. So that's how you do it. Okay? We'll stop here.